Hi there, this is Penelope. It's a short video on an example where we are using circular functions, which is what sine, cosine and tangent are, to put it in a really truly practical context. Okay, so we've got some sort of crankshaft moving around where you've got a wheel and connecting rods and all that sort of thing, and I've drawn the diagram, or copied it out of a textbook actually, but I've drawn the diagram to match the practical situation. And what we've got is that OP is rotating, and as it rotates, Q moves backwards and forwards, and how far it moves depends on the angle X, and you're asked to find Y. Find Y. Find an expression for Y. Find an expression for Y and then find the maximum and the minimum length of Y. Now you might be saying at this stage, oh, we haven't done any calculus yet. True, we're not going to use calculus. We're actually just going to use trigonometry and see how that works to find the minimum and the maximum. Now, we are going to have to use the cosine rule, and the cosine rule isn't part of this course. It wasn't actually part of the diploma maths either. It's assumed that you know the cosine rule. If you don't know the cosine rule, then check it out, look it up. I'll write it out here for you in the next slide. But the reason that we're using the cosine rule is that you use the cosine rule when you've got a non-right angled triangle, and for most of the time the triangle OPQ is not a right angled triangle. So in this case the appropriate cosine rule would be that L squared equals R squared plus Y squared minus 2YR cos X. So that's the cosine rule. So check it out. Now, by rearranging and completing the square, and there's a video on completing the square earlier in the course, so if you've forgotten that, just go back and watch that video. But by rearranging it and using this technique, completing the square, we've got that L squared minus R squared plus R squared cos squared X is equal to Y minus R cos X squared. Now, we remember, and this is why we use trig identities all the time, because they help us get out of a sticky place, so that cos squared X is equal to 1 minus sine squared X. So let's put that in. I'm sure you can tell I'm making these at home because my dogs are barking. And then if we expand the brackets, you'll see that the R squareds are going to disappear, and then on the left hand side we're just going to be left with what's the daisy? Minus like that. Okay, we could take the square root of the right hand side very easily, and then we need to be careful taking the square root of the left hand side and to take it of all, so that we've got that. And then if we rearrange that, because remember we're looking for Y, if we rearrange that, then we can get that R cos X plus the square root of L squared minus R squared sine squared X is equal to Y. Now the question asks us to find the maximum and the minimum. I'm just going to put in another slide. Okay, so I'm just going to write that again. So we had y equals r cos x plus L square root of L squared minus R squared sine squared X. All right, so we need to find the max and the min of Y, but we're not using calculus at this stage, because we haven't done calculus. Calculus comes next. Right, let's look at the max first. This is going to be when x is 0. And if you go back to the drawing, you can think about it, because when x is 0, the crankshaft is kind of flattened out. So look at the diagram. So it's going to be when x equals 0. So look at the diagram. And that means that y is going to be r cos 0 plus the square root of L squared minus R squared sine squared 0. And what we've got is that cos 0 is 1 and sine 0 is 0. So y is going to be equal to r times 1 plus the square root of L squared, which is r plus L. The minimum length, and this is going to be then when the bit is vertical, right over the other side, not vertical, it's gone through vertical and it's right over the other side, when x is equal to 180 or pi, then cos of pi is -1 and sine of pi is still 0. So this time now y is going to be -r plus the square root of L squared. So it'd be L minus R. And we could draw a graph of that. It's a cos curve. And we can put in pi. And we can put in 2 pi. Now we know that the maximum is going to be L plus R, or R plus L, and that the minimum is going to be L minus R, but that still has to be positive, so it's all going to be above the x-axis. So it's just going to be a cos curve that's going to be like that. Oops, it's hard to draw it like that. So there's that bottom there, and there's the max up there. So yes, it did use the cosine rule, but you can just look that up, and it does require a little bit of thinking about how the crankshaft is working and how it shortens and lengthens the length of Y. Okay.